The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the Women in Technology webinar today. My name is Kathy Kellenberger, and along with Ree Irish, we organize the chapter. And today is a special episode of our webinar. Melissa Connor from SentryOne will be talking to us, and this is actually a sponsored session today. We'll be awarding 100 Amazon gift cards to people that are attending. So I'll choose 2 people and I'll email them after the session to let them know that they won. So thanks to SentryOne for sponsoring our chapter. You make it possible for chapters in general to exist, but especially for our chapter. You can find more about us on the web. For example, you can see all of our videos on our WIT YouTube channel. You can find out lots of information about us on our homepage on pass.org. If you'd like to get our monthly newsletter and keep up to date on the news, be sure to join our virtual group. We have a Twitter account, and you can also email us at witvc@sqlpass.org, especially if you'd like to be a speaker. We're always looking for new speakers for our webinars. Our chapter has one goal we have is to promote women speakers, not just the ones who speak for our group. And to that effect, we'd like to call out a few sessions that are coming up. Kendra Little will be speaking for the data architecture group, how keys and columns work. Later this month, our group will have a session from Angela Tidwell, becoming the most valuable player, soft skills for the hard market. Tracy Baggiano will speak for us in July, Intro to Query Store, which is a very timely topic as everybody starts upgrading to 2016 and 2017. Bobby Jo Brighton will speak on women's mental toughness in the tech industry in August, and Jen McCown will speak for the DBA Fundamentals group on beginning admin, the care and feeding of SQL Server. So we try to keep up to date on all the sessions that are out there. If you are a virtual chapter leader, please contact us because we would love for you to also promote some of our sessions if they pertain to your topic. We also have a lot of women speakers that will be speaking at upcoming SQL Saturdays, and actually this morning, if you're in the US this morning, the PASS just announced all the speakers for SQL Summit. So starting next month, we'll also start promoting those as well. So there are SQL Saturdays around the world, as I can see here. This is just this coming weekend. Quite a few SQL Saturdays. Go out to our site or take a look at our newsletter to find out more. I can't go through all of these. There's so many. And today's session is all about data compression. It's been around for a long time, only an enterprise edition, but starting with 2016 Service Pack 1, it's available in all editions. And today, Melissa Connors is going to show us some of the benefits and things to watch out for when you're using compression. Melissa is a special project lead at SentryOne. She's focused primarily on performance testing, overhead analysis, and research projects for the SentryOne platform. She's the leader of Main Pass, organizer of SQL Saturday Main. She loves dogs. She's a friend of chipmunks, and she also loves to read. So I'm going to turn it over to Melissa. Let's see, unmute her, and then make her a presenter. Okay, Melissa, you should be able to take it over from here.
Okay, do you see my screen?
I see your screen. I'm going to go ahead and mute myself. If anyone has questions throughout the session, please put them in the question box, and I will let Melissa know Sometimes, like when she's changing changing slides, or an obvious breakpoint when questions come up. So she will be. We are recording. We will make that recording available. And Melissa, will you be sharing the slides and code later with us?
Yes, I'll put this into a blog post on the SentryOne website, and I'll tweet that out so it'll get out there.
Okay, sounds good, because that's the first question we always get. So thank you, and I'll let you take it away. It is a good question, and so I'll let you take it away from here.
Great. Thank you, Kathy, for the introduction, and thank you, everyone, for attending today. Kathy kind of went over and introduced this already. My name is Melissa Connors. I work at SentryOne. I work from home in the state of Maine, and I have that German Shepherd Trekker. I was very careful to make sure I didn't order anything from Amazon or something this week so that a delivery won't arrive during the presentation and he starts barking. Hopefully we can avoid that. I have a chipmunk named Dyson who just had babies, lots of pictures on my Twitter feed. And I also like to read books and bake cakes and cookies and all sorts of things. So those are the vital things that you need to know about me. I work for a company called SentryOne, who again is sponsoring this session. We provide software to monitor, diagnose, and optimize the data platform, whether that's virtual, cloud, or a hybrid environment that you have. We have popular tools like SQL Sentry and BI Sentry to monitor different areas. We also have Plan Explorer. If you're familiar with that tool or not, it's totally free. You can get that from our website. And that's great for DBAs, developers, anyone who wants to explore their query and look for ways to improve performance. Plan Explorer is the tool you should use for that. So on to data compression. The agenda that we have for this, some of the things we already mentioned with SQL Server Editions. I'm going to go over the basics of compression, give you some examples, walk you through a case study that I did with the SentryOne database, and then just kind of sum it up from there. And for some reason, whenever I think about saving the storage, I think about saving the whales, maybe because they're big, I don't know. But I have this whole whale theme in here on a few slides. As Kathy mentioned, SQL Server Editions with data compression, you used to only be able to use it if you had the enterprise license. But back in 2016, Service Pack 1, they took all of these features over here and made them available in the standard edition. So in addition to data compression, there's column store, which I won't talk about in this session, but also another type of compression that you could use. Partitioning, in-memory OLTP, all sorts of features that are made available now. So talking about SQL Server Compression, it's been around for a long time, and as Kathy and I were actually talking about before the session started, a lot of people that should be using it don't look into it because they're kind of concerned about performance or other things that might happen when they enable compression. And what I'm going to show you through these slides is that when you do it carefully and know what you're doing, the overhead isn't an issue. You can get a lot of benefits from it. It's kind of like when you apply an index correctly versus applying, 10 indexes thinking you're going to get better performance. If you do some testing and analysis, you can get really great performance and better storage from using the data compression. And I have a link here to the Microsoft document on data compression strategy, capacity planning, and best practices. They have a lot of information. That document's been out there probably since 2008 or so. Still very applicable and has loads of information in there and testing that they did within their own environments. And you'll notice that I have a lot of links on the screen for you. And when you get a copy of the presentation, the notes also have additional information and links, so plenty of information out there within the presentation. Compression methods. So when you have your data out there, it's just not compressed, none. That's kind of the default. And I joke around and call it the storage inconsiderate because it doesn't try to do anything to help with the storage. Row level compression is what I call kind of compressed or storage considerate. If you have trailing zeros out there and things like that, it doesn't waste the space. It can at least account for that. Page compression is what I like to call, it's actually compressed. It's actively going out there and looking for ways to compress the data with repeating values and such. So in most cases, if you're looking for the most compression, you're going to get it from page. And of course, you want to be able to see the before and after of what it would be. So there's this SP estimate data compression savings function that you can run, and you put in your table information, and you can see it'll show you your size with your current compression and requested, and you can do that by none, row, page. And you can see here that row compression, it doesn't offer a lot of compression in this example, but with page compression, it's almost 50% that you can see on that index. So again, it gives you all the indexes you have on there, partitions if you're using them. There's some additional information that it gives you over here as well, and I don't remember exactly which is which, but I think this one includes fragmentation, and this one might be fill factor and assumes no fragmentation. So those are just some additional calculations that you get with that, and they're documented at Microsoft if you want the exact details on those. So as I mentioned, row compression, it's more like smart storage. It doesn't waste things. So if you have an integer, which uses 4 bytes of storage, whether it's a single digit or it's over a billion, it's going to use the same amount of storage. And a big int would be 8 bytes, whether it was 1 or a billion. Things like the trailing zeros, the blank characters, it can at least not store those depending on the data type and what's going on. So this link that I have here from Microsoft, it has a table of the data type and how storage is affected by the row compression method. So you would definitely want to go through that to actually look at your data and see how certain columns may be affected by row compression. So on this example, I have the numbers table from AdventureWorks. It's just a single integer column. It's got 1 million rows out there. And when I look at space used, you can see it's almost 13,000 kilobytes for data. I run the actual script. This is like my fake demo. Not live, but running it still. Do the alter table, use data compression row, run that again, and you can see that you've got about 2,000 kilobytes that have been saved just on those numbers being stored smartly, not using the entire 4 bytes for an integer. With page compression, it does what row compression does, but then it also has these things called prefix compression and dictionary compression. So that's where it's actually looking for repeated values and things that it can store once or store part of versus storing entire values throughout the page. This example comes from Microsoft, and I kind of just altered it a little bit here. So on the left, there's no compression. You see all of the values here at the bottom. This page header area doesn't have anything. When we do the prefix compression, it took this value and just kind of said, okay, this is a prefix. I don't need to store it there. Then it looked at the value under there, and it took the first 4 characters and said those match that prefix. So it has the first 4 followed by a Q. Then when we go from prefix compression to dictionary compression, there are these 4 Q values that it now just stores there. It doesn't have to store them again. So that's the idea of how it looks through what's in your data, breaks it up with a prefix or dictionary, and compresses those by putting values in the metadata of the page. And there's a link here that goes over page compression implementation in detail. Here I have the numbers table on the left, and I looked at, again, the compression with none, row, or page. And I wanted to point out, because this is a table full of integers, row compression is as good as it gets. When I apply page compression, it's the same. It doesn't do prefix and dictionary compression on integer values. And that's explained in that table that I mentioned earlier where it shows the data type and is storage affected. So with numbers, row and page get the same amount of compression. On another table that I have, the person table in AdventureWorks, there's a lot more text fields in that. When I look at the amount of space used with row compression, it doesn't save that much on this table. But then you can see with page compression, it's not quite half, but it's, you know, considerably more. So when I was looking at data to compress in the Century1 database, and I was learning about compression in detail, I went into the pages because I wanted to see what was actually happening there, especially with the numbers. I was curious, does it look the same on the page? You know, is there anything that changes when you use row versus page compression on a number? And I just want to point out, you don't need to know anything about using DBCC end or page to use data compression, but if you're curious and you really want to look at it, these commands will help you do that. And Aaron Stellato has a great course on that and some resources that I've linked to. And I'm just going to go through them just so you can see what type of information you get there and how it can be useful. So on this command, I run the DBCC end, and I use the database table index ID, and I get all of these page IDs that I'll need to use. Paul Randall at SQL Skills has an excellent blog on the details of how to use this. To use DBCC page, you have to set trace on so you can see the results, and you run it. So you have the database name, file number, page number. So you can see back here, this is where I got the page number. And then I put that in here so I can look at the page. And then that shows column, the number associated with it. And that's how you can tell which page you're on and what you're looking at. You can see record size, the physical length, which is where when you compress something, that will change. So I looked through those for the numbers table for various numbers, and I did the compression, none, you know, the default row and page. Used this query here with this physical location cracker. There's a document here on how to use that, just so I could get all of the page numbers of the different numbers with the different compression methods, so I could look at them myself just to see what SQL Server was doing with that. So here I'm looking at just the number 1 with the default compressions off. You can see that even though it's a single digit, the physical size of that is 4 bytes. And over here you see n equals 1, so it's showing you column 1 is n, and the value 1. When looking at it at row, it goes down with row compression from 4 to 1. And you can see up here the record type now says that it is compressed. Looking at a number with page compression, it looks the same. So even behind the scenes, even though it's page compressed, it's still just the same compression that it could apply with row compression and appears the same way. I went through these just with different numbers to satisfy my curiosity. So I mean, if you want to look at that, that information's here, but I won't go through it in too much detail. You just see how when you get to some larger numbers, you know, 2 is as small as it can go with compression. And then 3 becomes the best. So overall, with the numbers, with no compression, they were 4 bytes each. Row compression and page compression, it saves some bytes, the same amount each time for the different numbers. And I have a blog post out there that goes through that in detail as well. If when you have the slides you want to follow along, all the information is there. So the more interesting thing to me is the person table, because that has more than just numbers in there. I ran a select using that physical location cracker just to find the page that had the most Melissas in it. So I used those scripts to get the information, and Melissa, well, first name is nvarchar, so it uses 2 bytes per character. So even though it's 7 characters, without any compression, that would be 14 bytes. With row compression, it goes down to 7 because it's able to get rid of that extra space. And with page compression, because there were 6 of them on this page, it's one of the values that ends up here in the compression info raw byte. So going back to that example that I showed with the SQ and L letters, this is kind of like what you see here. So I see Melissa is up there, and when I look at it on the page, the physical length is 0 because it doesn't have to store it again. And also there's this value for person type, which is repeated more than likely quite a bit. It also gets stored up there. You can see the integer had row compression applied to it. It's 4 digits and it's taking up 2 bytes of space. So using these commands, you can get in there and actually see what SQL Server is deciding to do with the compression. So now I've showed you how it works with repeating values and the prefixes. And I think knowing how compression works and what your data looks like gives you a mental image of, if you're thinking about using compression and you know your tables, mentally you can kind of get a list of which tables are more likely to compress well than others. So you could start your testing there to implement compression. And you also need to know a lot about the workload. So that's something else we'll get into. In the case study that I did, I looked at the Century1 database and I decided what to compress. I made some decision tables just to kind of explain why I picked some methods of compression versus others. And we'll look at which compression method you should use. And it's important to know that you don't have to pick just one. So if you have multiple indexes on a table, you might use row compression, page, or don't compress one of them. You can mix and match that all you want based on your workload and the data that's in each index that might compress differently. In this example with the Century1 database, I'm looking at the event source history detail table. And with page compression, I can see it's almost, not quite half, but you get a big savings using page compression with that table. So I explored that. There are multiple indexes on here, so I looked at all of them. The top has row compression and the bottom is page compression. And I put some calculations into the Excel sheet so that I could just see the percentage of savings. And I highlighted this one because it's the most. It's about 80% of that space could be saved by applying page compression. Then the question becomes, why does that particular index benefit so much from compression? So I see that there are 3 columns on this index. And I wanted to just do a count of what was out there and kind of look at the values. So there are about 250,000 rows in that table. The remote object ID is it's an nvarchar. There are only 241 unique ones across, again, about 250,000 rows. Unique event source ID, same thing. There's only 16 of those same values just across multiple pages and rows. The remote sequence ID, which is more unique, it's pretty much 1 per row here. Even though we don't get like the repeating values for page compression, it's a big in. So all of those smaller values that are taking up 8 bytes could be 1, 2, or 3 until you get into the really large numbers. So compression will definitely help with that. So that's something that you can try as well, in your database, kind of see, how many values are likely to be repeating and what data types they are. So this one, that we can see that it compresses very well. And looking at DBCC page, I just looked at some of those values where if there was no compression, The first value, again, takes up 16 bytes, 8, and 72. And this one, when I applied page compression, because in the metadata it was allowed to store some of those repeating values, it actually goes down to just 1 byte. So you have 96 versus 1. Huge compression ratio depending on the data. So this is an example of kind of your best case scenario. Another table that I looked at, again, row compression on top, page compression on the bottom, it actually, if you look at the ones that I highlighted, the compressed values are higher than the non-compressed ones. So that is something that can happen with data that you should not compress. And take a look at why. That index is a plan hash, which is a binary value. And if we go back and look at what Microsoft says it does with binary values, the best thing it can do is get rid of trailing zeros. And if you're not familiar with a plan hash, we look at that over here, you can see all the unique values, and there's not even a trailing zero on the ones that we see. And then if I do compress it to see what happens, you see that the physical length has stayed the same, 16 versus 16. But the size of the index is bigger because on this page now, SQL Server still tried to do something with metadata and put information in there for the compression, even though there was really no good case for compression. So it adds overhead space-wise, and that's why you want to be very careful about understanding your data before you compress it, because if it doesn't compress well, it's not just that it doesn't compress, you might be in worse shape. The number one concern that I hear about data compression and using it is the CPU overhead. So if you actually look at how the data is used, if it's mostly read, the CPU impact will be lower. If it's mostly updated, it'll be higher. It still might not be that high. You know, this is something that for every workload you need to test and understand how it's being used. And if you're using partitioning, you might have partitions of older data that really are only ever read, and they might be better candidates for compression than the active partitions where people are currently doing updates. By updates, I mean actually changing the data. Inserting data is fine. So if it's reads and inserts that are coming from the workloads mostly, that's usually a good case of something that could use data compression without having too much CPU overhead. Microsoft has a document out there as well as a script that you can run. I took the script that they had and made some changes to it. So instead of having one looking for updates and one looking for scans, I just combined that so that I could see the scans and the updates together. And again, this script is in the notes so you can copy paste it to use on your own. And it'll give you the table index partition information. And this one you can see based on the sort. I'm looking at ones that are just read. They don't have updates on them. And something you want to think about here, as you would with other things like deciding when to get rid of an index, is knowing how long the server has been up, what type of workloads might get executed, you know, monthly, quarterly, different times, to make sure that this is a fairly accurate representation of the workload on those tables before you make any, you know, snap judgments about the updates and scans. You just want to make sure it's been up for a long time. I made some decision-making tables when I was doing this, and the labels are completely arbitrary, but based on the test database that I was working with at the time in SentryOne, yeah, I just decided what was a small or a large table and where some of the most benefit would come from with storage itself when applying data compression. So those tables kind of looked like this, where I was like, here's the disk space, you know, how big it is, the percent savings by row versus page, scans versus updates, the decision I made, and just some notes to myself based on why I made that decision. Like at the top, page seemed fine based on the scans and updates and the amount of compression. If CPU was a concern, I could definitely look at row compression for that because the CPU overhead is slightly lower. So just knowing your workloads and tables, you can make these types of decision-making tables to explain why you chose one way or the other. During the testing process, I looked at the CPU overhead of using the different compression methods. This was with the Sentry1 database. So with one, that was just the overhead of monitoring one target. Since we are a monitoring solution, that's what I'm talking about with 1 versus 5 on the right. So you can see when I was monitoring one target, the CPU basically was the same for none versus row. It went up a little for page. As I started increasing the workload in general, it still didn't really go up. It's, within 1% of not using compression. So by applying it to those tables that have inserts and reads, but not updates, the actual CPU overhead from using compression, it was negligible, and the other benefits made it worth it. Now, before you apply compression, there are definitely some other things that you want to consider. The actual applying compression itself, this is a production environment in particular, it's kind of like rebuilding indexes, but a little worse than that. So you have the CPU overhead as well as the time of doing that. And speaking of index maintenance, it has some increased overhead once you're using compression. So if that's a problem for you, like resources on your production server, you just want to be aware of that so you can make a smart decision. Database backups, if you're using backup compression, the data compression is different from that, so you still get a little additional benefit. And then just be aware of your transaction log and tempDB depending on how you're rebuilding indexes. So the same consideration, I guess, that you have now for your index rebuilds, just with the idea of using compression will make that a little heavier. And I have some charts to show you on that. So with applying compression, this was the average with, I did this 2 ways. So this server that I was doing this on has 8 CPU. And I did it with max stop unrestricted and then max stop equal to 1. So when I left it unrestricted to apply the compression itself, you can see that the row used more compression. The red is the none, which was basically just rebuilding. So if there was an index where it was not compressed, I rebuilt it with compression equals none. So that's basically just rebuilding the index. Applying the row compression added more, about double, and then page compression higher from there. So if the CPU is a concern when you're applying the compression, you could set the max stop. If you set it to 1, then it can only use 1 CPU during that process. So you can see the max CPU, when you're not restricting it, it's obviously going to take as much as it needs at certain times. And if you set the max stop equal to 1 or whatever, it's going to be contained to that single CPU. So if you have some overhead concern on your server, that's one way to deal with it. The other thing to take into consideration is the amount of time that will apply to take to apply data compression. So here I looked at rebuilding an index where max stop is not constrained, so that's the red, and then max stop set to 1, so you can see that takes longer. And again, this is rebuilding an index as none, applying row compression, and then applying page compression. So page compression, when it was constricted to just 1 CPU, it really did take a lot more time. So you just want to balance that. Maybe, not max stop 1, maybe 2. All depends on your unique server environment and what concerns you have. As I mentioned earlier, when you defrag your indexes or do rebuilds on them, when compression is applied, those will take longer. Row compression, it's about the same. It's just over 10 minutes. But page compression actually doubled this particular index when I did the defrag rebuild. So that's something to keep in mind. And the CPU usage will go up higher when you're just doing a regular rebuild of that index. So in this case, the compression was already applied. This isn't applying it. This is just rebuilding an index that has compression applied to it. So there is additional CPU concern there. And this was just more of the amount of time it took to do a different type of defrag rebuild online this time. Row took a little more, and page again is substantially more. And then the database backup files. So without using backup compression on this particular database that I was using, you can see that you save a lot of space just from applying the compression. And when you use the backup compression, you still get a tiny bit more compression squeezed out between the data compression and the backup compression. So if you're able to use those in conjunction with one another and storage is a concern, you can certainly go ahead and do that. I mostly just wanted to point out that it's not the same thing in case people were thinking it's like the same compression. In addition to storage, you get performance benefits from using data compression. Since it stores it in memory, you have more data per page. So you get memory and disk I/O benefits from using data compression. As I was running a workload using my test environment, you can see when there was no compression being used, how much memory it was using. Applied row compression, it went down a little. And again, this was one target versus 5 in this weird test environment. But every time I applied a higher level of compression, the memory usage went down. So that is a benefit that you'll get. Disk latency as well. When there was no compression, this test environment had latency over 20. Row compression brought that down, and page compression brought it down as well. Because you can get more data per page, I also just wanted to show when executing a query, the amount of memory, the response time, the reads, all of that information in this table, it all proportionally came down. So when I ran it with no compression, that was the size, response time, and logical reads. I applied row compression. The savings for storage went down by 46%. The response time went down by the same percentage. Number of logical reads. So you can really see what happens there when you're using compression. Page compression brought that down even more. So in this example, using page compression, it didn't add an amount of CPU overhead that we cared about, and we saved memory, response time, I/O, so a lot of benefits there from just applying data compression. And here using the Sentry1 SQL Sentry, looking at disk-related weights. When I wasn't using compression, all of this orange here was disk-related weights that I had reading that data. After applying page compression, you can see that the weights go down, particularly for the disk. So it's a major benefit there, again, for I/O. And again, like if you're applying new indexes, when using compression, you just want to stay on top of the table usage. The workload might change, different programs that get run at different times. So your scans and updates might change, and you just want to check in on that. Routinely verify that the compression method that you're using is still the best option as the workload and application itself changes. So a checklist of what I went over. You want to first verify that the data does compress well. You don't want to make any assumptions about that. Get the information from those queries, looking at the scans versus updates, so you can understand the existing workload on that table. Then build your own decision-making tables to look at those scans versus updates, how much it compressed to decide, and how much savings you'll get to decide whether you want to pursue that. Always get a baseline before you make your changes. That way you actually can see and prove, the impact that the compression had, whether good or bad. But I expect, if you've done this carefully, you should see a much better baseline. Always apply everything in test, compare the baselines, verify the impact to your maintenance, as we went over with the rebuilds, and always continue to monitor performance. And I know this great software tool called SentryOne that can help you monitor your performance for that. So here's the exciting thing too. After you've applied compression, you've probably just saved a lot of space, but the system is still holding on to that space. So you have to make a decision at this point. Was your goal, because this is data that you're not adding to and you just wanted to save storage and have better performance, that you kind of leave it alone, or do you shrink it? So if you're not going to reclaim that space, if those tables aren't growing, you might shrink the file or database to release the unused space. But if you're going to grow into it, you might just leave it out there. No one ever wants to recommend shrinking, files or databases. It's like one of the worst things. But this is an actual use case depending on how your data is used going forward. After you compress it, you might want to shrink it. So that is up to you. And in the presentation, just some of the T-SQL that I used, I put that out here. And again, in the notes, you can copy and paste the actual queries to get to them. If you're curious about, if you don't know your database, whether existing data compression is out there, this query will go and select everything where data compression is greater than 0. So if it's page or row, it'll list the objects and index ID for you, so you can find those if you're not sure. If you want to apply compression to a table, there's the alter table rebuild script to do that. Important to remember that this is altering the table, so that might be a heap or the clustered index, but if you have multiple indexes, alter table doesn't go ahead and apply compression to those other indexes that are out there, so you can do those all individually. So alter index is how you would apply it to a specific index, and you could decide row or page, different ones across the table. And don't forget about the partition option. If you're using partitioning, you might want to apply this just to, some of your older partitions, depending on the workload and expectations. You could use alter index all, which would apply the compression then to every index on that table. You might not want to do that, but if you already know the workload and you've looked at the data compression per index, you can go ahead and do that. If there's something in there that will cause an error, like invalid usage here of data compression, the alter index or the alter index all will fail. So that's just something to be aware of. If you're trying to do it all at once, there may be something that prevents that. And if you want to incorporate the max stop settings, you can do that as well by just adding the max stop to the script. If you want to do 1, 2, or 4, whatever makes the most sense for your environment and how much CPU you have to spare. These are a bunch of links to blog posts on Microsoft best practices about that. So any information that I've mentioned in here, it's out there in a blog in detail as well. And does anybody have any questions?
We did not get any questions in the question box. However, I have one, and I'm not sure if you've looked at this. I've heard from some of the storage vendors that they don't recommend adding the compression feature because they do deduplication. Have you ever heard anything about that?
I'm not familiar with that. No, I don't have any experience testing that theory or, yeah, sorry.
Okay.
See if anyone knows, but I have not looked into that in particular.
Right. Well, my theory is, and I have not tested this, but my theory is that row compression would not interfere with their deduplication efforts, and that you should always go ahead, unless you're getting the extra, unless the table is so small that it's going to cause extra overhead, go ahead and do row compression because you're not getting rid of any duplicate data. With the page you are, obviously. So, I mean, that's my theory. I haven't had a chance to really test it, but I know.
Like your theory definitely makes sense.
Yeah.
And I would be curious to see that.
Yeah, because we're going to be storing the data on a smaller number of pages, even with row compression, and copying a smaller number of pages into memory. So I think even if the storage, I think pure storage is one of them that I've heard this from, even there, I think you're going to get a benefit, even if they are doing deduplication under the covers. So.
I think that would make for an interesting case study to look into that.
Yeah, I think so. I had a customer a couple of years ago. I was trying to talk them into doing a test, but I had to get them to cooperate with me to do it, and it just never happened. So that would have been an interesting thing to do. So anybody out there, if you have any questions, now is the time to put them in the question box, and we'll get them answered.
Yeah, and if anything comes up later, feel free to reach out to me. My email's there and my Twitter handle as well. So anything comes up.
Okay. Yeah, I think you did a great job of just making it very understandable for everybody, and you covered it very well. So that's probably why we aren't getting the questions, maybe.
I hope so. That would be nice. That's the reason.
Yeah, I think so. So I guess we'll go ahead and close up for, now we have a question. Okay. Most of our SQL servers are used with third-party software. Should I be checking with the vendors that they support compression? Great question.
Well, I think the vendors would always say that, yes, you have to check with them, and no, they don't support it. But I think in most cases, if you test that out and you're comfortable with it, I don't see why you couldn't do it.
Okay. Yeah.
Do you have any concerns like Kathy? So I'm just trying to think like what could go wrong. If you have a test environment, I would test that out with a third party, but in scenarios I'm thinking of, it should be fine to use.
Yeah, because it doesn't change any of the code.
Exactly. Like when I applied this to our Century 1 database, we didn't have to change anything in the code. It's independent of that.
So any other questions out there? We'll wait a minute or so. How do you start the next benchmark test after completing the row compression?
Not sure if they mean in particular how I did that. I used the Century 1 software to create a baseline before. Then I just ran the same workload tests that I had and got another benchmark to see how it changed it. I use Visual Studio as well to create workloads when I'm testing, but the baselines from that came from the Century 1 software, which has built-in baseline features.
Okay, that makes sense. Yeah, so basically you just have that time period you can look at to see before and after.
Exactly.
Yeah, if you don't have a monitoring tool, you'd probably have to set up a perfmon collection, something like that.
Yeah, you'd kind of have to manually do that or have scripts to collect things and then tabulate them through another program.
Okay. All right, I'll wait about another 30 seconds and then we'll close up. So thanks again for this. It was really great, and we just need to get the word out about compression because it's a great feature and everybody can take advantage of it now, and I would like to see more of it used more often.
I agree, and actually all those features, people might not be familiar with them because they didn't have a way to use them before, but take a look at what's out there now and see which features make sense for you to use, because it's so many, it's a lot more powerful what they've given everybody.
Okay, so we'll get the recording out on our YouTube channel. Melissa is going to post a blog with the code samples and slides today, or that she used today at some point in the near future, and then she'll tweet about that. What is your Twitter handle?
It is Malika Nokoi, which is on the bottom left of the slide that's on the screen right now.
Okay. Oh, yeah, there it is. So that sounds great. I will close it up, and thanks again.
Thank you so much. Appreciate you having me today.
Okay. Talk to you later. Bye.